is because you can actually put it on the model, and then if you put too much on, you can take it off. If you need more, you can put it on. It's almost a labor of love. I mean, you have to actually get very close to the model and feel how the transition from a hard radius goes to a softer radius. We can't do that on a computer screen. I mean, it's almost as if you can design the car blind. You don't have to see it, you have to feel it. And by feeling it, you feel if it's right or if it's not right.
The design work is obviously the first thing a customer sees. But underneath the skin, engineers have taken advantage of some of their Formula One innovations. Chief mechanic to racing legends Ayrton Senna and Alain Prost, Neil Trundle has worked with McLaren for over 4 decades.
You do 10, 15, 20 years of travelling, and then you kind of think you've seen every hotel and track. The passion doesn't go, but then you want to find a job at base, see the family. This is the F1 preparation area, where we prepare the cars for demonstrations, for testing, and also we prepare our old historic cars. This is MP41, the first carbon chassis Formula One car ever made. This is an old friend of the family.
The new car has its genesis in this Formula One car, the first to use a lightweight material borrowed from the aerospace industry, carbon fibre.
Everyone had narrow chassis, same kind of shape as this. But because of this inherently weak area here, the aluminium chassis were twisting. When we did the carbon chassis, we realised we achieved 100% stiffer chassis than had been made before. So suddenly our car was, you know, the leading technology. Some of the other teams said that it was a fragile material, that it would shatter, but all the accidents we've had in it proved that it was up to the job. And since then, carbon chassis have got stronger and stronger and safer. But this was the start of it.
Not only was the company's carbon chassis stronger and safer, but it was a lot lighter, which meant acceleration and handling were greatly improved. And applying these design features to the new road car has obvious advantages. In the 1990s, McLaren set the land speed record for the fastest road car at the time, 240 miles per hour, in this, the XP5. The secret was the carbon fibre chassis, called a monocell. But it took 4,000 man-hours to make and cost the lion's share of the £600,000 price tag, so production numbers were limited. But through precision engineering, strength like this can now be mass-produced by the company at a much lower cost.
How do you make a composite car, which is normally unaffordable, i.e. north of €500,000? How can you make the same car for